Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on correlation in linear relationships. Note that students are required to have a table of critical values that test the claim that the slope is not zero. This is a table that should say something at the top about correlation coefficient critical values or something similar to that. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 4 of this series. In the last video, we had just finished talking about this screen, and I want to review it really quickly before we get into the last part of these questions. If the correlation coefficient is positive, the slope is positive. We have a general trend of the linear regression going from left to right of going up, and as the x increases, the y increases. As the x decreases, the y would decrease. The x and the y do the same thing. X and y agree, so if everybody agrees, it's a positive mood. So they're doing the same thing, we have a positive mood. X, and that last is a way I keep it remembered. It's not a mathematical explanation. For the correlation coefficient being negative, the slope is negative, and we have a downward trend as we look from left to right in our linear regression line. As the x increases, the y decreases. As the x decreases, the y increases. The x and y do opposite things, and as a non-mathematical way to remember it, the x and y disagree, and in a disagreement we have a negative atmosphere. So if we're positively correlated, they're doing the same thing. If it's negatively correlated, it's doing opposite things. And when the correlation coefficient is 0, the slope is 0, our line is going straight across, there is no linear relationship because the linear relationships have non-zero slopes. Would you expect the following to be positively correlated, negatively correlated, or have no correlation? The number x being the number of people in a family, and y being the weekly grocery bill for the family. And this is general trends. Don't try to overthink these problems. As the number of people in a family increase, what should the weekly grocery bill for the family do? It should also increase. So they're both increasing. They're both doing the same thing. That would be a positive correlation. X is the number of workers putting up drywall in a 10-unit apartment building. Y is the time to complete the job of drywalling a 10-unit, that's not supposed to be until, but a 10-unit apartment building. So what's happening? We increase the number of workers. What should happen to the time to complete the job? X increases, Y will decrease. The number of workers increase, the time to complete the job will decrease. They're doing opposite things, and when the things are opposite, we have a negative correlation. So this is a negative correlation. C, the number X is the number of people who own red cars in a town and the average rainfall in the town. So let's increase the number of people who own red cars in the town. What is that going to do to the average rainfall for August in the town? I'm not sure what that will do. It doesn't seem that it would affect it in any way. Well, it doesn't. That means there is zero correlation. One does not affect the other. X is the yearly salary. Y is your income taxes. Don't overthink this one. The more money you make, the more you should pay in income taxes. We're not going by percentages or any kind of political views here. As one increases, the other increases. It's a positive correlation. X as the number of hidden security cameras in a shopping mall. Y, the number of shoplifters caught in the shopping mall. Well, as you increase the security cameras, what's going to happen to the number of shoplifters caught? X increases, this Y would increase. So they're both doing the same thing. We have a positive correlation. X, the cost of a 52-inch high-definition television, and Y, the number of 52-inch high-definition televisions sold. So as the cost increases, what's going to happen to the number sold? Well, the more expensive the television is, the less people are going to be able to afford to buy it, so the less the numbers, the fewer television sets that will be sold. So as X increase, Y should decrease. So they're doing opposite things. In this case, you may say this: if the cost goes down, if the X decreases, would Y increase? Yes, you'll sell more televisions if you put them on sale. So they're still doing opposite things. That gives us a negative correlation. Letter G. X is the number of birds that use a bird feeder, and X is the time it takes the full bird feeder to be emptied. Well, the more birds that use the feeder, so as X increases, what's going to happen to the time that it takes for it to be emptied? X increases, Y decreases. So that will be a negative correlation because they're moving in opposites. Here are some exercises for you to try. For those that I give answers to, remember, if you're doing these exercises for quiz grades, that you will need to show all your work to receive full credit. Thank you for watching, and as always, if you are a Walter State student and need additional help, it can be found by coming by the Math Lab in MBSS room 222 here on the main campus.